All right, this is 6-5, so let's get to it. All right, in 6-5, we get an opportunity to, let's try this again. All right, I think we're good to go. All right, so in 6-5, we get an opportunity to continue in our systems of equations and inequalities, but this time we're really looking at matrices and we're gonna dig deeper into those to get a better understanding of what they are and how they work together. So we're gonna be performing operations like addition, subtraction, and multiplication, and then we're gonna use a real world example to solve a matrix. So in general, we have this matrix, and then the first one we'll call A, the second one we'll call B. And IJ, that's how like you refer to the positions that the numbers are in within the matrix. So like AIJ, we have, let's say for example, A31, A31, that means matrix A. So go to this matrix, third row, first column. Okay, so third row, first column, that's the 9. Okay, so let's just use that knowledge to identify other ones. So identify B32. I feel like we're playing bingo. So B, third row, second column, that entry would be -2. It says compute A11 times B11 plus A12 times B21 plus A13 times B31. So we actually have to identify all these numbers first and then move forward with them. So A11 is 0, B11 is 0. So that'd be 0 times 0. Okay. I jumped too ahead. Then we say A12, so first row, second column, that's -1. B21, so second row, first column, that's number 2. A13, first row, third column, 6. B31, third row, first column, 7. So then when you do that, you just multiplying 0 times 0 is 0. -1 times 2 is -2. And then 42. So that equals 40. Okay. It says, if possible, find the value for X that makes A equal B. So looking here, this one matches this one, cool. This one matches this one, cool. So for this one to match this one, X would have to be 6, okay? But there's also an X in this equation, so let's see if they are true. So this is this, cool. 6, 6, that would work. So if X was 6, that's perfect. This is this. However, in this bottom row, the 9 and the 7 are in the same corresponding positions, but they don't equal each other. So these matrices will actually never be equivalent. Because the 9 and the 7 don't match, they will not be the same. So we can make X equal 6, and that's cool, but the matrices will still not be the same because they have a different variable in the same spot. Okay. Now, the second option is for us to learn how to add these two together. So when you're adding matrices, you're literally just taking the first and the second and adding them together. So from matrix A to matrix B, the ones that are in the same spot, these are called corresponding positions. So we end up with 4 plus 3 to get our new variable here, which would in turn be 7. Okay. For this one, we do -1 plus 3. And that's how we get 2. In this one, we do 4 plus 1. We get 5. Then we get -5 plus 0. -5. 1, -2. -1. And then 0 plus 4. And we get 4. That is our answer to A plus B. This is on your test. Okay. Can you add matrices? Now, what I'd like for you to do is let's end this slideshow real quick and show you how to do this in a calculator. Bear with me, but you also may just stop and pause and rewind and all of that good stuff. So let's get out of this system solver. Okay. From a main screen, you have matrices in your calculator. The best way to get to them, let's see, is it the math key? No. Lord, my brain is going blank right now. Hold on, y'all. Oh, I'm so silly. Above the inverse key, there is the word matrix. So if you go second inverse, then that brings up our matrix menu. Matrix A, B, C, D, E, F, G. They're all there, but they have not been defined yet. So you have to go over to edit first, and you'll go in and you'll define what matrix A is. So matrix A in our case is a three rows, 2 columns. So it's going to be a 3 by 2. So put in the matrix size, 3 by 2. And then you'll see something that looks similar to what you're trying to input. Put those values in. So 4, -1, 4, 5, -5, 1, 0. Okay. And so then we can go back to the matrix menu and go over to edit again. This time we're going to put in matrix B. Again, it's a 3 by 2. And this time we're just going to type in those numbers 3, 3, 1, 0, -2, and 4. So everything looks good. Make sure this is inputted right, because if it's not inputted correctly, then you'll get the wrong answer. Okay. So second quit. Okay, we've put in A and we put in B. That's the very first step, just to go into your matrix menu and type them in. We're going to go back to our matrix menu, and this time we're going to call them. So let's go get matrix A by pressing 1 and just say plus matrix B. And there's your answer. So it'll actually add it for you. And there we have it from the screen. Okay. That's it. Okay. So we can do the subtraction the same way. Well, the good thing is that these matrices are already input in our calculator. So, and they're the same as what we just had in the first option. So I don't have to go in and change them. Okay. So we're using the same matrices. I'm just going to subtract them this time. So I'm going to go to second. Let me make this bigger. I'm going to go to second matrix. And I'm going to say A minus second matrix B. And there's your answer. That's how we do it. Uh-oh. Okay. This answer is right there. Okay. We can also multiply by scalar. So 2 times the entire matrix. Obviously, that means you're going to take each entry and just multiply it by 2. So each of those entries is multiplied by 2. But you could also put in your calculator and allow the calculator to do this for you. So let's second plus 712. This clears everything out. So when you go to matrix, you're having a clear menu. So let's edit and put in matrix A now. This time it's a 2 by 2, 2 rows and 2 columns. And I'm gonna put it in 2, -3, 0, 3. Okay, so that's done. So now when I go back to my matrix menu, I can just say, call me matrix A and multiply it by 2. If I put in the 2 and then I put in matrix A, it's still gonna give me the same result. And that's the answer when you multiply the entire matrix by 2. So I'm giving you the way to do it by hand, but I'm also giving you an opportunity to learn how to do it in the calculator One, try it by hand and then just check yourself in the calculator. That's totally fine for me. Okay. All right. Next slide. How do you multiply by the scalar and do some other type of operation? My best advice to you is to put these both in the calculator to start with. I always clear my calculator in between. Second plus 712, second plus 712. And that clears my calculator. So I don't have anything that's like tripping on. I'm not tripping on nothing. Okay. So putting in matrix, too big. What am I doing? Sorry, y'all. Okay. Putting in matrix A. I'm going to go to second matrix. I'm going to go to edit. A. This time it's a 2 by 3 dimension. 2 rows, 3 columns. Okay. And we're going to go 1, -2. -2. 5, 3, -4, -1. So that's my matrix A. So I'm gonna go back to matrix, go over, edit, put in matrix B. Again, it's a 2 by 3. Okay, and I'm gonna put them in again. 0, -1, what is that? -5. And then it's -3, 1, and 2. Yeah. So again, I want to make sure I type it in right, because if I don't type it in right, my whole problem is wrong. Okay. So second quit, clear screen. Now I'm going to do this entire operation, okay, on my calculator. 2 times matrix A minus 3 times matrix B. And there's my answer. Using the matrix key in the calculator to actually perform these operations. That's all we're doing. Okay. So those are the 3 different things that you're going to have to be able to do. Are you going to be able to find the dimensions of the matrix? Can you add or subtract matrices? Can you multiply by them and do all of those things together? Okay. Now, moving to the application problem in here. In this text, we're actually going to think about pixels in photography. Okay. I don't know if y'all remember, but like when phones first came out, you would buy your phone based upon like the number of pixels in your camera, or buy a digital camera based on the number of pixels. So each pixel is basically like a little square. The more pixels you have, the better your image is, and it's not so blurry. So anyway, this is just an application of that. So suppose we would like to digitize the letter T as shown below. Each color on the color scale is going to be represented by a number. So white, gray, dark gray, and black. Okay. So right now we have 0, 0, 0 in these blanks, and that's white, 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 white. We have light gray, 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 and gray. And that's how we end up digitizing the letter T. Okay. So the matrix is basically 1, 1, 1, 0, 1, 0, 0, 1, 0. We can see the letter T even in the matrix. It's right here. Okay. Because those are the gray blocks versus the white blocks. Okay. So what if we want the entire image to become one level darker? So we basically say, hey, take all these gray ones and make them dark gray. Take all these white ones and make them gray. So we need to change gray to white. We need to change change white to gray and change gray to dark gray. So basically we're going up one level. So we're taking our initial value and adding 1 to the entire picture image. And by doing that, we end up with 2s, which would give us the dark gray, and now 1s, which would give us the gray in space of white. It says now, find a matrix D so that adding D to A causes only the T part to become 2 levels darker. So the zeros are going to remain zeros, right? So we're not adding anything to those, but we need to take this first row in the main column the center column, add 2 levels of it so it can become black. So that's how we add 2 to all of the T values. And we end up with a 3, which is black. But the white still stays the same. Okay. Now, what if we have this darker image and we need to go back 1 scale? That means we subtract 1s. Remember, but we're still keeping zeros in these other spots because we're not messing with those spots at all. And last but not least, how do we take this image that has gray spots and darker gray spots to black and white? So these gray spots were 1s. These were 2s. We need to make these 2s 3s. And we need to make these 1s 0s. So in essence, we're taking the 2s up 1. So in our new matrix, we're going to be adding 1s to all the 2s so they can go up. And we're going to be subtracting 1 from all of the other spots. So this is our matrix of change. And that will leave us with 3, 3, 3, 3, 3, 0, 0, 0, 0. And that's all. That's the application, y'all. So 5-6-6-5 is over, and that is the completion of the semester. Congratulations, and thank you so much. Let me know if you have any questions in class.